My name is Chris Vollmer. I'm a storage architect out of Canada.
Hi, my name is Joe Dane. I am the Chief Architect for Spectrum Discover.
Part of our conversation at TechU this week has been a lot around storage for AI. Part of the conversations has tended been, once I've got the inference, where do I go from there? Some of the conversations a lot of our customers are asking us, how does the inference change the everyday? Does it change something? Can it create an entirely new process? Can it create a new workflow? How can it change the world I live in? Some of these examples that we've been talking about this week we thought were really interesting. One example I kind of want to drill on for us around storage for AI is how we can leverage the storage to help build the inferences. In the use case we've been looking at today, it's around once I have an inference, now how do the tools around storage for AI actually help me change my everyday workflow? So in this kind of a situation, we have an example where we've built an inference already. We've used Power AI Vision, and we've used a lot of sampling already to be able to create an inference that understands what cancer looks like on a pathologist report, right? On a screen.
Yep.
Now that I've got that inference, we can leverage it inside a workflow. That workflow then almost augments what people can do. It can almost do a first path. It can help us figure out where to look. So as a radiologist or pathologist, it can help me understand where to look.
Yep.
So Joe, what I'm wondering if you can walk me through is, once we've got that inference, how does some of the tools that we work with in storage every day, like Spectrum Discover, happen? How does it work? What does it do when it interlocks with that inference, when it connects to that inference? How does it pull all those pieces together for us? Once we've got the inference, how does that work?
Right. Well, we have to first start with, well, what is the source data?
Yeah.
In this case, it's a microscope where they've taken samples from biopsies. They stain them and put them under a slide. And then they have a high-resolution camera that's taking pictures of the cells. And then we train the model so that you can then detect the tumors in the individual cells, and build this inference model for that. And so once we have that, now you can imagine in a hospital, you get millions of samples coming in all the time of biopsies. In the pathologists, they have to be able to understand what those are, and they have very high skills, but there's so much data coming in.
Yep.
If we can help them to be able to do this first level order of curation and understand what these samples are, it really speeds up the process, makes a better outcome for the patients.
So this is almost a speed to diagnosis, or a way to augment the diagnosis and get to a diagnosis faster, curate through however many samples that might be coming in at a given time, to be able to then say, okay, this is a diagnosis, you're clean, you're clear, you have something else. It lets you understand, okay, what's the first order pass. So walk me through that. In your example around that microscope, if we're in a hospital, the microscope would save the image of the biopsy, and it would save it down to, in this case, a file system, right? So very basic, goes into a file system like IBM Spectrum Scale.
Yep.
Okay.
Yep.
From there, how does it work?
Yeah, so data goes into Spectrum Scale, and then Spectrum Discover builds a catalog of all these new images that are built, and we do some tagging on that so that we can understand, what was a patient ID that this came from, what was the microscope, what was the brand of the microscope, what was the magnification that took place.
So some of that tagging comes out of the metadata of those objects or those images coming in?
You can do it both ways.
Okay.
So if, like, for example, in an image, there's metadata that's embedded in the headers, and we can extract that and put it in. In other cases, the tags that you do are more mapped to your hospital, for example. You know what particular department it comes from. So as this data comes in, you tag it. And so you can understand where it's coming from and be able to search on those tags. Say, this came from a pathology department, and this came from x-rays, this came from CT scans, that kind of thing.
So building on that idea probably of an information architecture, you start to lay out that, okay, they're coming in from this department, this source group. I already know who's sending them to me and a bunch of the characteristics, so those tags automatically get applied to the data sets.
Yep.
So I can use kind of institutional knowledge to build some of that first level curation, right?
Absolutely.
And then where do I go?
And then what we actually orchestrate a workflow where we'll read the images out of Spectrum Scale and pass them to our Power AI Vision inference model.
Okay.
And now this Power AI Vision inference model will take a look at the image and say, oh, I detect a tumor, ductal carcinoma or whatever it may be, and it gives the label, the classification output along with the score confidence factor.
Okay.
So let's say it's 90% confidence that this was ductal carcinoma. And Spectrum Discover will then take that output and add it back to the catalog. So now you have the output from the inference, the actual AI labels that were generated, along with the organizational constructs from the hospital that you mentioned, and that allows you to really curate and understand your data. And now, let's say, for example, I want to search on a particular study and I want to understand the confidence factor in the results of it, I can find the outliers. So anything that has less than 90% accuracy, I can go to Spectrum Discover, search on those images, and quickly find them and pass them off to a pathologist to take a closer look at it, or retrain the model, or take further action.
So let me walk that back. So once the inference has examined the new samples, as they come in, the inference that we built goes off and says, great, I'm going to look at all these new samples. When it determines, okay, it's a benign or malignant, and there's my confidence factor is a certain level. It's 95%, I'm really sure, or this is one that I haven't seen before as the inference almost, so I'm not sure, so I assign a low confidence factor. This gets you the ability to go, okay, now those outputs have to go somewhere, right? And that's part of the idea of once it's figured out the individual file, you're relating that data, the output data from the inference, back into the original data set. That's kind of what we're describing, right? We're able to say, what's conclusion has the inference drawn? How confident is it? Now, how do I relate that back to my original core data set so I can understand both the inference's impression of what it's seen, or the inference's conclusions on what it's seen, against source data? Is that about where I'm going?
That's it. Well, the point to add there is that we're actually doing it at the individual image level. So for every biopsy that comes in and that image coming from that microscope, it gets sent to the inference engine. We understand the output of it, and now we apply those tags into our catalog. So you build this catalog of billions and billions of images, and within a second you can search on that and find whatever you're looking for in the individual images that map to that particular criteria. So if you want to do, again, I'll go back to the ductal carcinoma example. If I want to find all of my examples of positive, 90% accuracy for ductal carcinoma, I can search on that in Spectrum Discover, and it'll give you each and every image that you can then take further action on.
Gotcha. So then if I was the radiologist or the pathologist, you could also go in and say, okay, which ones was the system not very confident in? Let me start to understand those, because those ones maybe need a second and third and fourth pass either through a couple of radiologists, or they go into another kind of workflow, versus the ones maybe as I'm starting to curate and understand what the assessment was from the inference, then I can start to say, okay, the ones that are high assessment, let me look at those, because I also know where to look, or I want to know where to look depending on what that inference can do, right?
Right.
And all that gets done through the ability to search against all of the tagging that we've now associated to those individual files, and that lives inside inside Spectrum Discover, right?
Right. Well, the interesting thing about it, there's multiple actions that you can take. When you have these inference models, there's a continuous retraining of this that needs to take place, and so one action.
Oh, that's a good point, because then you can have data scientists search as well, right? Is that where you were thinking? Yeah.
So one action is that you have these low confidence factors. You get these, and then you go to retrain your model so you can increase the accuracy of it, and it's this continual process. Those images that have the low confidence factor, you may also send them off to the pathologist to have a human eye look at them as well.
Okay, so then you can start to say, okay, I've got this continual cycle of now as more files or more scans come in, I can actually push that back through the training pipeline, so that I can start to improve the inference.
Absolutely.
Okay. How else does Spectrum Discover see this? So as it sees data, it's going to be able to create that catalog, it's going to create that reporting. Then we're able to also then assign those tags. But at the end of the day, it starts to make the output of the inference more searchable, as well as the original data set more searchable to the radiologist, the pathologist, or even the data scientists, right, that are building the inferences?
And it also really automates the process.
Oh, talk to me about the automation a little bit.
So as the images are coming in, they're automatically being sent to the inference model and classified.
Gotcha. So I'm automatically tagging as it comes in and understanding, okay, here's the classifications and the stuff. And then talk to me a little bit about the score, because now we've got the score, we're able to understand how confident it was, and then make decisions based on the confidence levels as well, right?
Yeah. I mean, so any inference model is going to tell you there's a score confidence factor, and if you index that, now you can search on that confidence factor to be able to find the outliers, things that aren't performing well, things that are performing well, and take further action on it.
Awesome. Thank you very much. That's been really cool. And from my perspective, I think this is one of those things that actually has an impact to be able for us to make a difference in the way things are done, the way the diagnoses are done, and actually use an AI inference to impact workflow and speed to answers for people we work with, for our customers, and for our partners. So
absolutely.
Thanks again.
Thank you.
My name is Chris Vollmer. I'm a storage architect from Canada.
Joe Dane, Chief Architect for Spectrum Discover.
Thanks very much.